Hello everyone. Today we're going to take and true up and dress out a CBN wheel. This is an 8-inch wheel. It's from Continental Diamond Tool. It's got 75% concentration. It's got a 1/4 inch of resin bound CBN material right here. And I already did a little bit of prep on this. One of the things that they do is they have a little lip that was right in this area of aluminum that was probably 1/16 of an inch. I always like to cut that back on the lathe and on both sides because I'm going to be truing up the sides of the wheels, because this is one of the primary purposes I use CBN. They work really great for side wheeling material. They also work real good when you sit your spin fixture up and for OD grinding. This is 150 grit. I think that's considered medium. But anyhow, I'm going to be dressing with this type of diamond tool here. And I'll have Kathy get a close-up here. Do I need to come closer?
Stop right there.
Okay. If you can look right in this area, this whole area is got diamond, and they call them a grit dresser. And they will actually cut the CBN. They won't cut diamond, but they'll cut CBN. And you can use these to true them up just like you would a regular grinding wheel. And they also sell these grit dressers, which I just found out when I bought these for doing regular wheels. So pretty soon I will probably order some for those. This one's are special for CBN. They may work for a regular wheel. I might even try them on that. But basically they got a real tough matrix that they say on their website, with a lot of uniform diamonds that are in here, and just by spinning it I can see some of the diamonds glittering in there. So there's quite a few in there, but they claim on their website it's the most economical way to dress your grinding wheels, and I would believe that, because I know when we get these, they last, for CBN, they last a long time. And so I already started a little bit, and so the wheel's a little bit dirty. Continental Diamond Tool, I always like their CBN and diamond products. I've been ordering from them for decades. And I already just took a few thousandths just to see how much kind of dust this was going to kick out, and as well as I wanted to make sure that this was the right diamond tool for cutting. And this comes from Continental Diamond Tool. It already has the CBN. If are you close enough? You can see this, Kat? You can see the glittery. You can see that glitterly, that sparkle in there. That's your CBN material. When we true these up, you're not going to see that, because what's going to happen, we're going to be cutting the CBN material and the resin. It's all going to be at the same surface area, and so that's where we will end up using these white sticks right here to cut away the resin material. Now when your white stick, you want to use a real soft grade. These are A, and they're at least 220 grit. They may be a little bit higher, but you always want to have a finer grit on your white stick than what your wheel is. My wheel is a 150 grit. This is at least a 220 grit. If you go with a smaller or a more coarse, like say if you'd use 100 grit and you have a 150 grit wheel, what's going to happen is your grit size is going to be too big to cut the resin around the particles of your CBN. So you need a finer grit size so that you can get in and cut the resin away from the CBN, because you want the CBN to be exposed. And this will kick out quite a bit of dust, so Kathy and me both will be wearing respirators, because you don't want to breathe this nasty stuff. And before we get started, I'm going to see if we can get Kathy to come up and see if we can get a close-up of the wheel, what I got currently dressed. So anyhow, I just got this little light out here, and I'm just kind of going back and forth so you can see all the sparkly material on the sides over here. What I've been doing is dressing the bottom, and you have a dark spot here and a dark spot there, and that's where it's cleaning up, and the resin is getting it to the same surface as what we have with the CBN content. So it needs further dressing, and so Kathy's going to back up to protect the camera from the dust and zoom in real tight, and we'll put our respirators on, get this started, and start truing that wheel up. One of the other things I wanted to point out too is because that's got an aluminum hub on there, and these do generate heat when you're dressing, and if that heat transfers through the resin and it starts heating up that aluminum. Aluminum's got a high thermal expansion rate, and what will happen is you'll ruin your CBN wheel because you'll start getting cracks all the way around it, and then they're not going to be too safe to run. So I got my coolant where I'm trying to flood it real well, and when I put my respirator on, I'm not going to be talking, but I'm going to be taking very light cuts, just 1 or 2 tenths at a time. And it's going to take a while because it is breaking down here as it's cutting there. So if you take off 3 thousandths, you might only get about 5 tenths, maybe a thousandth off the wheel. So anyways, we'll get started on that right now. That was 3.5 thou that I took off. Now I want to look at the wheel. The other thing I'm listening for is if it's grinding all the way around on the entire traverse. And it was throwing more powder out when I first started. It actually seems like it's cutting better now. The other thing I can do is I can feel this surface right here. And I can feel that that's nice and smooth all the way around, over there. If I go on the side, I can feel the grit. Over here, I can't feel anything. It's nice and smooth. And so I'll probably stop right there because it looks like it'll be pretty darn good. And I think I took a total of about 6 thousandths, 7 thousandths off with both passes that I want on my digital, but I probably got about half of that over on the wheel. But I don't feel any grit going anywhere out on there. So what I'll do, let me wind this up and pull it. One of the other things that I've done on this is that I pulled the diamond, I pulled it a little bit further this way because I got this in a holder that's straight up, and I didn't want to have a lot of surface cutting off of this point right here. And so I pulled it off so that it would cut more down in the back side there. Okay, now one of the things that you're going to want to do when you use these white sticks, you want to use them after they're soaking in the coolant for a few minutes. They will just, it's very porous, it will penetrate all the way down in there, and you're going to want to run the coolant on the white stick and as you dress this wheel. And as I start pushing this white stick in, and the grit will start cutting some of that resin there because there's no exposed CBN, what's going to happen, I'm going to have to put a little bit of pressure to get in there. Once the CBN starts cutting, I won't have as much resistance. When I first start, I'm going to feel a lot of resistance. As it opens up, CBN is exposed, I won't have that much resistance, and then that's one way when you know you're getting real close to having it perfect. And the thing of it is, if you use these sticks dry, they're very aggressive. They'll cut that resin real fast. So you definitely, when you want to do your finish operations in there, you want to soak it in coolant. One of the things they tell you when you use these resin sticks, they want you to actually turn the wheel off and then let it spin down as you go. and you never let the wheel stop while you've got pressure with your stick in, but you want the slower RPMs. When I'm first cutting and that resin is tough and I got to put pressure on, I just leave it on until I can feel it cutting free, and then I'll turn it off and on. And depending on what wheel, at my full-time job when I'm truing up a 12-inch wheel that's a half-inch wide, I'll use at least a half of that stick. I probably won't need as much on it for this, but we'll see what we need. We're also going to want to have the coolant. Up here so that we're keeping everything cool. It helps a little bit with the dust, but you can see I'm pushing pretty good on there. And now you can see it cutting freer. So I like to get it where it's cutting a little bit free first, and then I'll turn it off, let it slow, back on. Right now I can tell that I need a little ways to go yet because it's not cutting this as free as I want yet. So I'm just going to leave her on for a little bit. Worst case scenario, I can get too aggressive and then I'll have to true it up a little bit again. It actually feels like it's cutting pretty good there. So you don't want it to stop on you. Yeah, it's cutting real free now. You see, we used a fair amount of that stick, and I think it's pretty good, but you're never going to know until you take a cut with it how good it is. We'll open this up. I'm going to dry my hands off. We'll open this up, and we'll see if we can look at that wheel again. Yeah, so now you can see that, one, you can feel, it feels rough because I opened up that resin. Plus you can see the shiny, sparkly CBN over there. You can see that is exposed the cutting edges pretty well. So what I'm going to do next, what we'll do next is we'll set this tool in this holder, and then I'm going to dress and get both of these flat on both sides. I'll do this off camera. And then I'm just going to hold it by hand, and then I'm going to kind of cup it because I just want a thin lip for side wheeling, so I'll just cup it. And I'll do that. I'll use a white stick on it, and then we'll come back and we'll do a test cut with it and see how it looks. Actually, I thought it might be a good idea to show at least this front side because you could see in the other pictures that we did, you can see the structure on here. So I want to dress this off and show you, because you can get a clearer shot what that structure looks like. Okay, we're just now touched. I'm going to put my respirator on and keep my mouth shut. That was 5/1000ths on the digital. And so if you look at this, you can see that this the dark spot is what was actually cutting. I can't see it real good with my glasses. I have to take them off a little bit. But you can see the CBN. You can still see the original surface on a lot. So even though I went in about 5 to 6/1000ths in there, I only have about a 50% cleanup on there. So we'll do it a little bit more. That was 10/1000ths total. We'll see what it looks like from here. So right now what we have is we started from where I could hear it touching. We went in 10/10, and it's got a nice surface, and I'll let Kathy come in and try to get a close-up, and then you can go back and look and see the difference. But right now that's smooth all the way around, so that's got my resin and my CBN at the same surface. I'll dish it out by hand yet, but I'll do that part off camera and using the white stick off camera. I got to do the back side, but we'll let Kathy get a nice close-up if she can. I don't know if this light's going to help. And as you can see, you don't see the glitter quite as much.
The light is actually messing it up.
Okay. How about that?
I think that's better.
Yeah, so you don't see the glitter as much. You don't have exposed CBN. So like I say, it's smooth all the way around. You don't feel any roughness at all. And so it looks like it's 100% cleaned up. We'll clean things up to the backside. And when we come back again, we'll be set up and we'll be doing some grinding with it. What we're going to do is we're going to take and we're going to grind the bottom of this and side wheel. On there are going to be two about 1-inch spots on both ends that we'll clean up, and then we can see how it's cutting from there. And the CBN I don't like so much for cleaning up like bottom surfaces, surface grinding. It works great for OD grinding, but it seems like it loses a little bit of its outer roundness if you get too aggressive with it trying to hit the like this bottom surface here. But we'll see what happens. I've never ground with the 75 grit. I've always had 100 or 75 concentration wheel. I've always had 100 or 150, and this is a 75, and that's what Continental recommended. So I'm going to get this set up and get it positioned, and we'll take a cut, and that's how you're going to see how well of a job you've done. When you take the cut, if you see burn marks in there, and then that means we don't have enough resin removed, not enough CBN exposed. If it's cutting and you know, you can tell that it's cutting up high rather than low, it's not relieved enough. We want the lip to be down at the bottom. Well, I got everything set right now, so that I just cleaned a little on the bottom. We'll come over here and clean the side. I raised it up a few thousandths. We'll move into the side cleanup, and then I'll bring it down. I liked when I grind on the bottom, I like plunge grinding rather than coming down, coming across, because then you just start wearing an angle on the wheel. I like to keep this as flat as I can. So right now we're going to do some side wheeling. This is DC 53. It's at about 62 Rockwell. Very hard to cut. Got to work a little bit getting the coolant position better. What we'll do is we'll take this off now and move it to the granite table, and we'll get some pictures of it. And what we're going to be looking for over here, we want a real nice clean grind. If we see burn marks on there, then we know that we need to use the white stick and open that CBN up a little bit more. If there's no burn marks and it looks like we got a real nice grind pattern in there, and then everything will be correct. Okay, this is the part that we were testing, and a number of things I want to look for is we're going to show you this face first, because I'm going to use this primarily for side wheeling and stuff like this, because it's DC53 and other steels. When you get past 60 Rockwell, the aluminum oxide wheels, they just create lots of heat. You get burn marks. So if the resin is cleaned out proper on the wheel, I'll be able to grind this surface, side wheel it. It'll be nice and straight all the way up and down, where a lot of times the aluminum oxide wheel, you got a lot of push off, and you have a little bit of a taper that comes down. It'll be open up here and closed down here. But anyhow, what I look for, if I want to see if the resin removal with the white sticks is good, I won't have any burn marks in here. If the resin is hitting a little bit with the CBN, you're going to get a little bit of cut, but the resin's going to rub, it's going to get hot, and you're going to have some burn marks that you'll see in there. And so you won't see the burn marks. So we got a good cut. We know that it's just the CBN that's touching. The other thing I look for in there, I look for on that pattern. You can see the pattern of the wheel as it goes through. If the lines are real thick, that means my lip is too wide. I need to thin it out. And so it's a lot freer cutting if you got a thin lip on there. Now if you got too thin of a lip, then it's going to break down too fast. So you get that sweet spot in there, and it works out pretty good. So one of the benefits with that CBN, I'm not sure if I mentioned this before, is it doesn't break down like an aluminum oxide wheel, not near as fast. It will break down, but it's slow. If I take this CBN wheel and I get a cleanup cut over here, set my digital at 0, and slowly wind in up to 5 thousandths, just going a few tenths at a time, get up to 5 thousandths. If I would have measured it, I would probably have the stock removal is going to be really close, because there's very little breakdown. So if I wound over 5, I would probably get 4.5, 4.8. I'd get very little breakdown. And so that works really nice, because when you're sizing something in without the wheel breaking down, you can use your digital and grind this stuff a lot faster. So anyway, this is the finish on the side, and what I did, and we'll try to get this set so Adam can see, here's the bottom finish on there. And this, keep in mind, is plunging. There's no traverse going back and forth, so this will be the roughest, because I plunged down. When I run an indicator across here, it'll show you how flat that wheel was, and I'll do that over here. I got it preset, and so you can see as I'm moving across there, we got probably less than 2/10 where that wheel's flat. And I know there is a high spot on it on the back side, and that's where you can see it drop, and it's only about 1/10 or 2. I can easily take that out with a white stick, or I can just let it break in, because that little bit will break in very fast. But as you traverse across, a high point will hit, and that will be the first part to wear. But you can see just with the plunge, that actually come out really nice. So it's a good job there. What we're going to do now is we're going to show some OD grinding using the CBN wheel. Other benefits with the CBN, they cut very free, they cut very cool. I won't even be running coolant on this. And I'll just be taking a few tenths off a pin so that you can see the finish on the OD, as well as, you know, just regular surface grinding here. So we're going to cut away while Adam sets up, and so we can get a good angle on the grinder. I've already cleaned this pin up a little bit, so I'm just going to take a cleanup cut on here. Just taking a few tenths at a time. And with the CBN, you really don't want to take more than maybe a thou on the side, because then you start getting into that resin material. If you're plunge grinding, you just ease it down. I like to keep the high point on this side of the wheel over here. Right now it's on this side, but if I keep the high point on this side of the wheel, if I got shoulder work anywhere, I know that if I come down at the shoulder and come across, I know that my smallest diameter will be up against the shoulder. And I always like to start with my grind this way and traverse that way, and I do that for a reason too, is to keep that high point on the front edge of this wheel. What we took over there was about 4/10 of an inch per side, about 8/10 altogether. Always like to take a blank pass, take out any wheel pressure, flexing or whatever. Now what I'm going to do at this point, I'm going to wind down and I'm going to bump this face because it just got a cutoff wheel on there. Is what I use. It's a very rough surface, and then that way we can take a look at that as well. And again, this shoulder work is where the CBN really shines. And if you get aggressive with it, and then you're going to want to run Kuhlman, I'm just going to try to take it nice and easy so you can hear how interrupted that is. I don't know if I have 100% cleanup, but we'll pull this off, throw it on the granite, and take a look. Now here you can see the finish that we have on this part. And like I say, the ODs, they tend to give you a nicer looking finish. The wheel seems like it works a lot nicer on there. That's primarily where I use my CBN. But you can see how good it is running. The other thing with the CBN, I can have things sticking out a long ways because there's so little wheel pressure on there that it will cut real nice. And what we'll do now is we'll show one other thing. We'll get this turned and Adam can look at the face, and then we'll get a micrometer and we'll check and see how nice it cut this way. 497, 2.5. Let's see, let me get a good feel on here. 497, 2.5. 497, 2.5. Now, one of the things that we did to dial this in is, if any of you guys have been following my Instagram account, you can see I've made a fine adjust tool so that I can adjust for taper in this part. And I don't know if Adam can get a picture of it. It's sitting right down here. And we're going to try to throw some of the Instagram stuff that I put up in this video to show you what's happening. But I have a wedge shape design that I've done in the past, and what I have, I think it's in about 1.5 inches. I have a 3/4 degree angle riding down, so with the 1032 screw, when I push this wedge up, it will rise for each revolution. If I remember right, it's about 4/10 of an inch. So if you end up with 50 millionths tape or whatever, you can adjust that out really well. And So anyhow, that's mounted underneath here. I have this up on risers. It gives me more room here. Plus I can fit that fine adjust tool out here. And it actually establishes 3-point contact with the 2 screws in the back of the unit on each side, and then one right there in the middle. So that works real nice. And so one of the things that I did, just for kicks, I wanted to see how fine of an adjust I can get. And well, again, we'll throw the Instagram video, but here's a differential screw. And I just want to talk about these things a little bit because some of the guys on Instagram wanted to know more about what's going on over here. But anyhow, with this differential screw, what I have is I got a 1/4 28 thread in this side. I got a 1032 screw in that side. So when you wind this screw in this way, 1 revolution, I'm not sure what the numbers are off the top of my head, but you're going to wind in a certain amount this way, and the 1032 is going to wind in a certain amount that way. So what you would have if you'd set up an indicator and you set it up in the front, I'm not going to do it, if you'd set it up like that, what would happen is if you wound that screw 1/1000, this would wind in about 4/1000. So that's what the differential screw does. The 1/4 28 is pushing that way, the 1032 is pushing that way. So the net sum of 1 revolution is that this block will move just a little over 4/1000. So when I set this up, and we'll show you the video from the Instagram, when I set this up using that wedge design, so that a full 1032 turn, which would move it about 31.2 thousandths per revolution, is what it said over there, and is pushing a wedge that's on a 3/4 of a degree angle. What will happen is I would get that part to rise about 4/10. Now by putting this differential screw in there and adjusting that, my rise, because 1 full revolution of this 1/4 28 pushes that 4.4 thousandths in, and at 4.4 thousandths on that wedge at 3/4 degrees, if I remember right, the math works out to a rise of 60 millionths of an inch per revolution. And obviously, if I wanted something real fine adjust, I can develop this unit like that to get that really fine adjust. Bet what I have over here with just the wedge unit is more than accurate enough here, because my pivot point is back on my screws. I'm raising this front edge up. My work is over here. So if I got 2/10 tolerant or 2/10 taper, I got to raise this up quite a bit, because if I raise up on the end here, I'm also raising up here because my pivot point will be back here. So that's how, if I was 2/10 out, I'd have to have about 2/10 from here to here. Is actually what I got on the taper, but because this is going up and this is going up, I have to actually adjust quite a bit more. So anyways, that little wedge adjusting tool down here actually works really nice to take out any taper that you might get. So anyways, this will be it for this week. Thanks for watching. We'll see you next time. Right now I'm working on a fine adjustment tool that I'm going to use in conjunction with our new spin fixture so that I can take the real slight tapers out. Right now I got this set. There's a dowel on this movable block. It's set to 0, and I got this set with a 3/4 degree angle, and so with 1 complete turn of a 1032 I should be able to get about 4/10,000ths difference, and so we'll see what we get. And we're just about perfect, 4/10, and that's for every turn of the 1032 screw. It'll move this block 32 thousandths over, but at a 0.75 degree, that will raise this position of this pin just by 4/10. Getting a little crazy here. I'm using this differential device I built a while back. For every revolution, it will move that block only 4/1000ths. I have this set at 0. I'm on the 5 millionths resolution scale, so each of the marks is 5 millionths of an inch, and if everything works right If one complete revolution of this screw should raise that pin, it should raise it by about 60 millionths of an inch. And it's really hard to get it on top, but what you can see right there is just a little bit over 50 millionths. That's with one complete revolution of the screw, and I'm getting a 50 millionths rise. And if everything worked out right, it should be approximately 60 millionths. But for doing something with a fine adjust, this can really dial things in for you.